Okay, so we're going to continue our circle units. Remember, I'm putting all the circle stuff together, so I'm pulling from the different sections so we can just do it, get it over with. We will do area, circumference, and all that with our volume. Okay, so we have a circle here that's cut up into some parts. Yes. So we need to name those parts. Okay. So this right here, I'm pointing towards a mark that marks an angle, yes? Yes. And we're going to name this angle, for the most part, we're going to name it theta, which we've used, right? Yes. Okay, and we could name it alpha, beta, omega, like anything we want. We use Greek letters for that, but we're just going to stay with theta for the most part. So that is called the central angle. And again, we're going to call it theta. Okay. You notice that this box points to this right here, this arc right here. Mm-hmm. And this box points to this, which would be the remainder. So they are called arcs, but this big arc is called the major arc. And the major arc is the largest arc in the circle. Okay. And so if this is the major arc, guess what the other one's called?
Minor.
Minor arc.
Wow.
So creative.
I know. Now, real quick, this, well, we'll do this major arc first. Okay, the major arc is from B
To C.
to A.
Oh.
But we have a problem. Because if we named it A to B, which it should be alphabetical, right?
Yeah.
Were we talking about this one or this one? So what we have to do when that happens is we have to have another point. So this major arc would be called A, C, B. Because you put them in order. And you put a, guess what, over it?
A line.
Not a line, an arc. You have to have, when other things can be named, just like with an angle, like I couldn't name an angle P if two angles used P, right?
Yeah.
So I had to use 3 letters, so here you have to use 3. Okay, so a minor arcs are any other arcs in the circle. Okay, so this one is pointing towards what? AB. So it would be arc AB. But is there another minor arc? Really?
Yeah.
What about BC? Would that be a minor arc? Yeah. Now it doesn't have a radius connecting it, but it be another one. Yeah. So we have BC. Could we have another one?
Yeah.
AC. Okay. So there are other possible minor arcs, but there's only one major arc because that would be the largest. Make sense? Okay, so these 2 boxes are pointing to this thing and this thing. What are those 2 things?
Legs.
Well, if it was a triangle, yes, but of a circle, they are the what?
I don't know.
The radius.
Oh, yeah.
So I have 2 of them, so they're called radii.
Radion.
Radii.
Oh,
Ew.
you can just put one eye.
Nope, gotta have 2. Okay, so they're called radii because there are 2 of them. Okay. This actually forms something that we'll talk about on the second page. This piece right here. And there are 2 of them. There's like one here, and then there's a big one here. And the last thing we have is pointing towards that right there. What is that?
Center.
The center. It's the center of the circle. What is the name of the circle?
P.
P. So how do we say circle without writing the circle? Circle with a center, right?
Mm-hmm.
Circle with center P. That circle right here, Says circle with center. It's 3 words in that one little picture. Circle with center P. Okay, so those are some parts of the circle. We're going to name some more like sector and stuff like that, but not right this second. So the total measure of a circle is what? How many degree are in a whole circle?
360.
360. So if I knew theta, could I find the other angle? Yeah. If I knew the other angle, could I find theta?
Yeah.
Because I would subtract from 360. Just like with a triangle, I subtracted from 180, right? Okay. So a circumference of a circle was capital C. And you should know this. It's been something that's been taught to you several times in your math career.
Y equals almost supposed to be.
No. Circumference of a circle is the outside of the circle, yes?
Yeah.
Can anybody remember that equation?
No.
Nobody?
Not 180.
2
180.
Ooh.
pi.
Yeah, I've never learned that in my life.
Yes, you have.
I've never learned anything pi related.
Yes, you have. 2 pi r. Okay, so pi circumference is, okay, 2 pi r. 2 pi r is the circumference of a circle. They haven't explained to you what pi is. I'm going to explain to you right now. Pi is the ratio, okay, ratio means a fraction, yes, of the circumference of the circle to the diameter. Okay, so that's what? It's that you don't ever have to calculate it. It's approximately 3.1428, blah, blah, blah. In our world now, with our calculators, because we have it, we only use pi. We don't type in 1.3. We have pi. When you do work in here, unless we're in IXL and it says to the nearest tenth or whatever, we leave pi in our answers. Okay? So we would leave the pi symbol there. Pi is a number. It is not a variable. So it doesn't change. It's just a symbol for a variable. A number.
It means enough said.
Okay. So we are going to come up with an equation for arc length. So arc length we tend to call S. See how this is arc right here? We call arc length S. That is the variable we use. And we are going to come up with the formula. So don't write anything next to the X. We're going to come up with the formula down here, and then we're going to write it up here and use the formula that we find. Make sense?
Yeah.
We're never going to find it again. I just want you to know where it comes from. Okay? So if I have a circle, right here I have a circle, yes? And the whole circle equals 360 degrees, correct? And I have this angle right here that it says n degrees, but we're going to call it theta. So theta is a fraction of 360 degrees, correct? Like a third, a fifth, a 1/18th, whatever. But it's a fraction of 360 degrees. Would not this length from here to here that we are calling S, wouldn't that be a fraction of the whole circumference?
Yeah.
Yes. And those ratios are equal. Just like we had ratios in triangles that were equal, we're going to use that ratio math to find this formula. So we know that the ratio of the angle to 360 degrees is equal to the ratio of the arc length, and I'm going to write arc length on here, which was equal to what? What variable? S divided by the whole thing, which is the circumference. And I'm going to write circumference, but the variable we use for circumference is what? C, and it's a capital C. So in the first one, I'm going to write equals C. So from now on, I can do C and S, which would be nice, better than arc length and circumference, correct? Okay, so if I'm going to find the arc length right here, that means I need to solve for this up here. How do we solve a ratio? We multiply by the denominator, the circumference, yes? So we multiply both sides by circumference. Now the letter C. Is this the same math we did last unit, solving those ratios in the unit before? Yes. So the circumference on the right reduces out, doesn't it? So we're left with arc length which equals S is equal to what? What's over here? Theta
Theta
times circumference divided by what?
360.
360. Okay, so theta is theta. We don't know it, do we? But do we know what circumference is?
Yeah.
What?
I don't know. I'm just saying, yeah. 2 pi r.
Don't we know circumference is 2 pi r?
Yeah.
So we're going to substitute that in. So S equals theta times 2 pi r over...
Can you move your thing? I can't see
Oh,
what you're writing.
sure.
Thanks.
So, now, there is no operation in between all of that, so we know it's multiplication. Yes? You will see some people rewrite this as 2 theta pi r over 360. Are these all the same thing? Could I write the numerator in any order I wanted to? Yes. So, this right here is going to go right here. So theta times 2 pi r divided by 360 degrees. So this formula, do you need to remember it?
Yes.
Yes. Okay, so when I'm finding arc length, I just need to plug in theta, which is the angle, correct?
Yeah.
2 is 2, pi is pi, r is the, what's r? Radius, and 360 is 360. So the only thing you really need to know is theta and r. Make sense? So it's that equation. Next. Okay, so what is the measure of angle APD? So APD. So that's this angle right here.
Yeah.
How can we find that?
Adding up all the other ones and then subtracting.
Yeah, adding it. So 360 minus what? 73 plus 43 plus 104. Okay, so 3 plus 3 is 6 plus 4 is 10. So 0, carry 1. So 11, 12. So 120. So 360 minus 120. So 240 degrees. That wasn't hard, was it?
How does that equal 120?
Because 3 plus 3 is 6, yes? Plus 4 is what? 10. So 0, carry a 1. And you have 4 and 7, which is
11.
plus 1. 12. Okay,
Yeah,
let's do it
tell me
this.
how that works.
104, 43 plus 73. Yes?
Yeah.
Okay. So this is 10. Carry a 1.
5 plus 7.
So that'd be 12.
Carry a 1.
So 220.
Oh, 220.
See, all
I
right.
forgot.
No
I forgot to
way.
carry my other 12. Sorry. So it's not 240. It's what? 140. Thank you, Jenna, for asking. I forgot to carry it over. Okay, so that's pretty much it. Yes?
Yeah.
Yeah.
Okay, this should be a nice smooth arc over here. I couldn't find one, so it's kind of pointy. Sorry. So what is the length of what? AB. So that means arc length, right? So I need to use what formula? S equals, give me the
S equals theta
theta
2 pi r
2
divided
pi
by
r
360.
divided by 360. Okay, so I need to plug it in. So what's theta going to be? So AB is right here, yes? I want this arc length right here.
Yeah.
So what's the angle? 73. I'm listing parts. I need to know radius. What's the radius?
Radius is
4.
4. And I need anything else?
No.
Nope. So now let's fill it into our formula. S equals, what's theta?
73 degrees
73 degrees times 2 pi times, what's R?
R is 4.
4. Once I put numbers in there, do I need to put parentheses?
Yeah.
Yes. Okay. Now I probably should reduce some, shouldn't I? Does 4 go into 36?
Yes.
Yeah.
80.
How about 90?
Yeah, you're right, 90. Sorry.
So 4 goes in here 90. I'm pretty sure 2 goes into 90.
Yeah.
How much? 45. So I now have 73 pi. Oh, and there was a degree here and a degree here, so they reduced out. So there's no more degree. Over 45. Now, 73 does not go into 45. 45, there's nothing like 45. I have 3, 5, 9, 15. Those don't go into 73, do they? No. So my answer is 73 pi over 45. If I needed an approximation, what would I do? I would put it in my calculator. I would put in 73 pi divided by 45. And my approximation would be approximately 5.1.
Yep.
Right? So if it doesn't tell you an approximation, this is what you put. If they have a unit here, you have to put a what? Unit. One more example and we're done for today.
Do you have any other tissues in here?
Back.
Are they out over there?
Yeah.
I guess I'll share my good ones.
Stash.
Oh yeah, because they're on. I have one. Okay, so try BD on your own.
God, get the ankle.
We're trying BD on our own, Sarah. Amber. We're trying BD on our own.
What?
The next example.
I didn't fall asleep.
Mm-hmm.
I wasn't. I was
Mhm.
asleep.
Just like she wasn't.
I totally was.
I wasn't.
Wait, my degree comes down. Okay, on mine, there's like a. Okay, never mind. Mine stopped working.
Did you get it? What was tricky about this one? Just a little bit for a second, probably.
The 447 or 45.
Yeah.
I stopped.
Yeah, because you have to get to BD, you'd have to go what?
All the way there.
This. And I probably shouldn't have written BD because I could have gone this way, huh?
Yeah.
Should I have written BCD? Yeah. Let's change that. Let's fix it.
I have messages
So
in
B-
the office
CD.
for actual statements.
Okay. So now we were lucky because I already done this up here and I knew that the 2, the 4, and the 360 went down to 45, didn't I?
Yeah.
And then 4 plus 5 is 9, and 1 plus 4 plus 7 is 12, so 3 goes into it.
Yeah.
Okay, so no homework tonight.
Enjoyed and adjusted